explain the different types of nozzles used in fuel injectors. We know that during fuel injection, when fuel pressure becomes sufficient enough to lift the needle valve, the S-fuel goes through the nozzle and gets sprayed into the combustion chamber. Nozzle plays a very important role in the fuel injection process. It is responsible for the following functions. The main function of the nozzle is to atomize the fuel particles for obtaining proper and quick mixing of fuel and air particles. Nozzle is also responsible for distributing the fuel to the required areas for its quick spreading. If fuel particles strike the cylinder walls, they decompose and produce carbon deposits which cause smoky exhaust and increase the fuel wastage. It is the responsibility of the nozzle to prevent the fuel particles from striking the cylinder walls. In case of non-turbulent type combustion chamber, nozzle is also responsible for the mixing of fuel and air particles. To cater to these functions, several different types of nozzles have been developed, chief among which are single-hole, multi-hole, Pintle, and Pintaux nozzles. Now let's discuss each of these types in brief. Let's start with the single-hole nozzle. Here, a single hole of order 0.2 mm is provided at the center of the nozzle body, which is closed by the needle valve. Injection pressure of these nozzles is around 8 to 10 megapascal, and the spray cone angle is around 15 degrees. The major problem with these nozzles is that during part load conditions, as the needle valve does not lift completely and the fuel pressure is quite low, which tends the fuel to dribble instead of spraying. Also, their spray angle is very narrow, which creates problems in quick and good mixing. Moreover, due to the presence of only one hole, very high injection velocity is required. Now let's discuss multi-hole nozzle. Here, around 4 to 18 holes of the order 35 to 200 mm are evenly provided in the nozzle body. Injection pressure of these nozzles is very high, around 18 megapascal, and the spray cone angle of individual hole is around 20 degrees. The major advantage of these nozzles is that they distribute the fuel properly in the combustion chamber, even at low turbulence in the combustion chamber. Also, due to the presence of many holes, very high injection velocity is not required. Now let's discuss Pintle nozzle. Here, stem of the needle valve is extended to form a cylindrical or conical pintle, which protrudes through the mouth of the nozzle. Injection pressure of these nozzles is around 8 to 10 megapascal, and the spray cone angle is around 60 degrees. The major advantage of these nozzles is that during part load conditions when the needle valve does not lift completely, the pintle blocks the orifice partly, thus increasing the fuel pressure. Hence, dribbling of fuel is avoided and distributed spray is obtained in the combustion chamber, which results in quick mixing of fuel and air particles. The increased fuel pressure also prevents carbon from depositing on the nozzle hole. Finally, let us discuss Pintaux nozzle. It is a type of the Pintle nozzle with an auxiliary hole drilled in the nozzle body, used to inject a small amount of fuel in the upstream direction prior to the main injection, which reduces the ignition delay period significantly. The main advantage of these nozzles is that they provide a better cold starting performance. This is because in cold starting and at low speeds, the needle valve lifts very less and most of the fuel is sprayed through this auxiliary hole, thus fulfilling the fuel requirement and resulting in complete combustion. Now let's summarize the different types of nozzles as